Alright, ladies and gentlemen, today we are going to be learning about square roots. I want to introduce this by talking about the area of some parallelograms. So two students found the area of parallelograms. Two students found the area of parallelograms. Okay, first student, Brad. Here's how he found his area. Hopefully you remember a parallelogram, that's a four-sided figure, opposite sides are parallel. The way that they find it, the area, is base times height. So Brad said his base was 2.5, his height was 6, so his area was 15 centimeters squared. Colin, when he found his area of his parallelogram, again he used base times height. He said his area was 8 times 8, so his area is 64 centimeters squared. So here's my question to you guys. Out of these two parallelograms, one of those is a square. So I want to know whose parallelogram, back and right, is a square, and why do you think that? So pause this video, have a little discussion, and which one do you think is a square and why? Alright, Colin has the square, and we know it's a square because 8 times 8 is 64. 8 is the side lengths, both sides are the same, and in a square, all sides are congruent. So Colin is the square. We're going to use this to start talking about something that's called perfect squares. And when you visualize a perfect square, it will make a square. To find a perfect square, it is the product of a number multiplied by itself. So I'm going to list out the first 15 perfect squares. The first perfect square is 1, because 1 times 1, or 1 squared. The next one would be 4, 2 times 2. Then 3 times 3 would give you 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, which is 100. 11 times 11, which is 121. 12 times 12, 144. 13 times 13, 169. 14 times 14, 196. And then 15 times 15 is 225. Now I could keep going. I could take any number, multiply it by itself, and that's going to give me a perfect square. Now I'm going to show you what that looks like. So if I draw this square right here, this is going to be a 2 by 2 square. What is the area of this square? To find the area, I would do 2 times 2, or 2 squared, which is 4. So this demonstrates what it means when you're actually talking about a perfect square. It will make a square. Will every single number make a perfect square? No, only certain ones. 2 will not make a perfect square. 3 will not make a perfect square. But 4 will. Here's what 4 looks like. Oh, actually, I just did 4, sorry. Here's what 9 would look like. If I had perfect square of 9, that means my side lengths were 3. Because the area is 3 times 3, or 3 squared, which is 9. And I can demonstrate this for any of these. And I'm not drawing all the little lines in this, but if I wanted to say the area of this square was 100, what would the side lengths have to be? This side would have to be 10, and this side would have to be 10. Because to get that area of a 100, I have to do 10 times 10, or 10 squared. Now we're going to take this knowledge and we're going to work kind of backwards. We're going to be talking about something called a square root. Our symbol for a square root kind of looks like a division symbol, but it's kind of got this little arch thing right here. And if you're looking on your calculator, this green one right here above x squared, that's your square root symbol. When you're finding your square root, it's like you're undoing the perfect square. You're finding basically the side lengths of that square. So for example, if I have this square that has an area of 81, the square root of 81 equals what number times itself gives me 81? Yeah, 9. So the square root of 81 is 9. Okay, what about if I have a square? That's not a good looking square, but I have a square that the area is 49. What are the side lengths? So in other words, I'm asking the square root of 49 equals 7, because 7 times 7 is 49. We're not actually dividing by 4 or dividing by 2. You're trying to figure out what number times itself gives you that area. All right, I'm going to make a little cheat sheet for you to help you with your first so many perfect squares and your square roots. So I'm going to list the perfect square on the top and then the square root on the bottom. The first perfect square is 1. The square root of 1 is 1 because 1 times 1. The next perfect square is 4. The square root of 4 is 2. Then 9, which would be 3 because 3 times 3 is 9. Then 16, because 4 times 4 is 16. 25 would be the next one. I'm just going to fill these out. If you need to pause to catch up, that's fine. I'm going to make 2 tables because I want to give you several of these to help you out. I personally think you should have the first 15 kind of memorized. Those are the ones that you're going to be using the most often. And 121 is 11, 144 is 12, 169 is 13, 196 is 14, and 225 is 15. Seems pretty easy so far, right? And it doesn't get too much more complicated. But I do need to share this. Square roots can have 2 answers. Now, why is that? Because how do I get another number? 2 times 2 is 4. What other number times itself is 4? 3 times 3 is 9. What other number times itself is 9? So let's talk about 2 times 2, which was 4. There's another one, though, that when I say something times itself will also equal 4. Now, the most common mistake answer is people want to say 4 times 1. Yes, 4 times 1 is 4, but this is not a perfect square. So 4 times 1 will not work. The factors have to be the same. So what else could it be? If you need to pause and discuss a little bit, you can, to see if you can come up with it. Right, you have to remember that numbers have a positive version and a negative version. What is negative 2 times negative 2? Negative times a negative is also a positive. So your square roots have a positive answer and a negative answer. Most of the time, we just use our positive square roots. So, for example, if I found the square root of 25, look back up at your chart if you don't remember. Square root of 25 is 5. So that means it could be positive 5 or negative 5. And the way that you might see that written is they might write a plus sign and a minus sign and just the 5 one time. Square root of 81. That's 9 or negative 9. So I can write it as plus or minus 9. All right, let's talk about working some questions. So if it says to evaluate, evaluate means to work the problem. Now parentheses are going to become very important. If there's parentheses around this and you're using your calculator, you have to include the parentheses. This stands for negative 7 times negative 7. Negative times a negative is a positive. Okay, 2/3 squared. Don't panic just because it's a fraction. 2/3 times 2/3. Multiply straight across. 2 times 2 is 4. 3 times 3 is 9. Now this one be careful on. If you notice right here, there's no parentheses. We are not squaring the negative. This wants the negative version of the answer. And you can look at this as it's saying negative 1 times 9 squared. I can break that apart if I need to. But basically that's saying I want my 9 times 9, which is 81, and I want it to be a negative. Okay, just a couple more things. Square root of 9 over 16. That looks very scary and complicated. You can break that apart. 9's a perfect square, 16's a perfect square. So I'm going to take the square root of 9 over the square root of 16. The square root of 9 is 3. The square root of 16 is 4. Now in the past, my students have a hard time remembering this. 2 root 64. Now, a lot of times you say square root or root. This stands for 2 times the square root of 64. Please write that down because you will forget that. Find your square root first. The square root of 64 is 8. Once I take the square root, I no longer need the symbol. I've used it. 2 times 8 is 16. This one says 5 plus the square root of 121. Do your square root of 121 first. So that's going to be 11 plus 5, which would be 16. And again, if it doesn't ask for both answers, we tend to usually just use the positive version, especially when you're working problems like this. Right, on this one, negative 3 times the square root of 225 plus 10. Do your square root first. And if you don't know how to do these, Watch how I can use my calculator. And you need to make sure your calculator is out of scientific notation. You'll hit second, and then your square root symbol. 225. If you don't get out a whole number, you get another square root symbol, that means it's not a perfect square. Now, order of operations, you multiply first. Negative 3 times 15 gives me negative 45. Negative 45 plus 10 gives me negative 35. Okay, one more like this. Square root of 144 minus the square root of 36. Find your square roots first. Square root of 144 is 12. Square root of 36 is 6. 12 minus 6 is 6. Okay. Here's something very important. Squaring and square roots. They are inverse operations. They undo one another. Just like adding and subtracting, multiplying and dividing. All right, one last question. A group of 225 students need to be arranged in a square formation for a halftime show. So this is very realistic in the band. They do a square formation. How many students should be lined up in each row? So here's my band formation. It's square. I have 225 kids to line up in this square. For it to be a square, our sides have to be the same. So how do I figure out how many kids in each row? You do the inverse of squaring. The square root of 225 is 15. So that means you'll have 15 rows of 15. 15 students per row. All right, you are going to have a Delta Math to do on this and a practice worksheet. Use your time wisely and get everything done. Have a great day, guys.